Hi, this is Mark Malberg of Digital Metrology, and today I'd like to introduce you to OmniSurf3D. OmniSurf3D is designed to make 3D surface texture analysis easy. So let's get started. When you first open any software package, you wonder, what do I do next? Well, we can make that easy also. Let's grab a data file and drag and drop it into OmniSurf3D. That's it. We now have a 3D model of the surface that we can drag around. If I use the mouse wheel, I can zoom in and out. If I hold down the control key with the mouse wheel, I can stretch it up and down. So we have the basic tools at our fingertips to explore our data. Now, 3D surface texture is just like 2D. There are some analysis things that we need to do. Often these are difficult to find and they're difficult to understand. So these are easily grouped together in OmniSurf3D underneath the Analysis menu, Analysis Settings. We're going to look at these toolboxes that OmniSurf3D provides kind of in order. So let's get started with preprocessing. When 3D surface texture data is measured, we often encounter bad data points. For example, this surface has holes in it. These are pixels that didn't return to the camera or the imager very well, and the instrument says, I don't know what to do with them. OmniSurf3D, on the other hand, does know what to do with them. If I look at our settings, we have the option of filling in those points. I recommend the linear fill, which is a bilinear interpolation that fills in these holes. Now, I am currently looking at the raw data. So let's go here to our plot selector and choose preprocessed. The preprocessed data had the fill applied. In fact, it records it on the screen what we've done. We've done preprocessing of a linear fill right now. So we took the raw data, we preprocessed it via the settings menu. Preprocessing, linear fill. Preprocessing gives us other options for removing outliers, for inverting the data, perhaps if we've got a replica surface. But let's move on to geometry now. The geometry tool gives us the way of establishing a reference through our data. So let's choose preprocessed plus geometry. My current geometry is a plane. So preprocessed plus geometry shows my preprocessed data with a plane running through it. It's not very interesting on this surface, but let's take a look at this surface. This surface, you can see there's obviously some tilt, and we can see how the reference geometry, a plane, fits through this data. That plane can be leveled when we look at the form suppressed plot, and these are the surface residuals relative to that plane. So the reference geometry is an important aspect of surface texture, and OmniSurf3D gives us the ability to see how that reference geometry fits. For another example, let's look at this plateau hone surface. This is measured inside a cylinder. We see that the reference geometry of a plane does not fit this surface very well. So we can go to our analysis settings and choose a cylinder as our geometry. The reference plane fits quite nicely now. If we move our way down to the primary surface, we see that that plane has been leveled and we have a great view of our surface. Let's go back to a plane and load a different data set. So I'll go back to the plane and pull in this data set right here. Our plane fit through the data like this, and when we leveled it, we have this kind of surface. This surface has some waviness. If I were to describe the roughness of this surface, I would need to get rid of some of these humps. So that's where filtering comes in. Filtering allows us to choose the wavelengths that we care about. Right now we have the standard roughness domain, 2.5 micrometers up to 0.8 millimeters. This roughness domain means that we're going to use a waviness filter to remove these lumps. Let's see how waviness fits into that data. So I've added a transparent waviness data set on top of my primary data, and I see that it wiggles around a little bit too much. Let's lock the scale for now. So we double-click the scale to change it. Anything we don't like in OmniSurf3D, we double-click to change. So let's zoom out just a little bit, go 500 micrometers to -500, and that calmed it down a little bit. With that, let's look at waviness. Yeah, this waviness to me has too much variation. These pockets I want to treat as roughness. So I'm going to go back to my primary and waviness, go to my settings, and increase the filter cutoff wavelength. If I do this, it will make the waviness a little smoother. We see how now it just follows the general trend. By the way, we can change the transparency on that trend if you don't want it to be too strong visually. I like to go around 50%. And we can also look at that waviness by itself. So we see that smooth surface that's being fitted through the primary as essentially a reference to get to the filtered data. That reference, that waviness reference surface, is interesting by itself. Sometimes we want to look at two representations of the same surface independently. OmniSurf3D gives us that tool. We can add a second map. This little icon here shows a rectangle in the top right. That relates to this rectangle I've just added here. So I can look at primary and waviness, and I can also look at filtered at the same time. Now it would be very nice to be able to relate these features here to these features over here. And that is exactly why OmniSurf3D has a synchronize button. It's like two chain links, so we can link these two images together. So now as we move one, the other moves along with it. If I zoom one, the other zooms along with it, and we can relate these individual features to each other between different plots. Now this particular data set does have some weird features in it. There are some points on the right-hand side that just don't belong to it. They were bad points when we imaged the surface. We have a cropping tool at our disposal in OmniSurf3D. It looks like a rectangle with handles here on the toolbar, or the analysis menu says Data Cropping Tool. This is very powerful. On the right-hand side, I have a selection zone. You can sort of see the little handles, but it's easier to just grab the middle of it and move it around, and we can see the handles much more clearly. Since my bad pixels were on the right-hand side over here, I can relate that to the right-hand side over here, and let's crop the right-hand side out of this data. Let's remove those pixels along the edge. If I hit OK, it will recalculate on this new zone, and we have a clean image. Our filtered data is exactly over that good region of data. When we have filtered data, it's important to be able to describe this with numbers. The parameter section of OmniSurf3D gives us a list of numbers. We can get here through the settings menu and choose parameters, or back to the theme. If you want to change something, double-click it. If I simply double-click in the parameter section, I'm taken to that same settings screen directly to the parameter page. I want to add some parameters now, so let's add the peak height. I can select it, click the Add button. I might add other parameters along the way, or I can double-click a parameter to add it. Similarly, I can remove a parameter by selecting and removing, or double-click the parameter name. Some parameters, like material ratio, have settings. Parameters that have settings are allowed to be edited. So again, if I want to change the settings, double-click them. Let's go 10 micrometers depth. Now also, parameters that have settings are allowed to be duplicated. You noticed I added SMR as a parameter, and SMR still remains in the list, so I can add it again. And on this one I can use different settings. Let's go 20. And I can add it again. This time let's go 50. So these different representations of the same parameter are based on different settings. When I OK this, I'll see calculations for all of those parameters. The parameters that have settings will show the settings directly below the result. So OmniSurf3D gives us the full suite of parameters and visualization, but sometimes it's hard to remember what these things mean. For example, SA, SQ, SZ are surface texture parameters. The OmniSurf3D help system gives us definitions for those things. I can go to Definitions, Parameters, and choose any of these and be taken to a description of that parameter. All of the parameters in OmniSurf3D come with friendly descriptions, along with the associated ISO standard if you want to dig deeper. Now that's the parameter section, but while we're in help, let's look at getting started. If you're ever in doubt regarding where to begin in OmniSurf3D, hit the Getting Started section of the Help System. It will talk you through pre-processing, reference geometries, filtering, and parameters, the 4 things we've just talked about here in this video. Now, the last thing that might be interesting for you is to actually make some measurements of your data. I just dragged in a new data set. This is a turned surface. However, this data set has a different size than the one we're currently looking at. We did some cropping on our current data, and this new data is a different size, so that cropping may or may not apply. OmniSurf3D prompts us, do you want to reset the cropping? Yes, I'm going to reset it to no cropping again, and here's our data. Let's look at the primary surface, for example, and I don't like my vertical scale since it was based on the old stuff. This time let's click on the axis itself and just simply auto scale it for now. So now that we've loaded this turned surface, it might be interesting to make some measurements along a profile. Let's slice through this surface with a cutting plane. So I'll go to the toolbar and show the cutting plane, which has handles on the edges, and as I drag these handles along, we can see a profile graph. The profile graph has the option of cursors. Let's turn off the Y cursors and look at the X cursors by themselves. If I place a cursor on this high point on the surface, I can look at the distance to the other cursor right here. One is 3.96, the other is 3.52. We could do some math and figure out what that distance is. But OmniSurf3D can do the math for you. If I double click on this cursor position, I can make it a cursor 0, and now my cursors are reported relative to that position, and I can see that my spacing is somewhere around 46 micrometers. So we can measure spacings that way with the X cursors. We can put Y cursors on the profile and measure heights the same way. A double click sets a cursor 0, double clicking again takes us back to global coordinates. So cursors are a useful way of making measurements along a profile. We can also look at the wavelength content of that profile. We can see what wavelengths are present in this data. This particular profile has a strong spike at around 46, 47 micrometers, just like we saw with our cursors. That's where the spike is in the wavelength content graph. And as I move around, we can continue to watch this spike updating. We're also able to see the filter transmission. Our current filter is 2.5 micrometers up to 2.5 millimeters. If I change my analysis settings, change my filter, say maybe 0.8, let's go to 0.25 millimeters in fact, and go up to 25 microns. This new filter band is going to update in this corner. There's the new filter band. When we did a recalculation, the cursors rehomed, so we'll bring the cursors back into play, and we can see that our filter data is now working in a zone more compatible with our data. In fact, I could move that lower cutoff down a little bit and capture that spike quite nicely. So instead of 25 microns, let's go to 8 microns and move our cutting plane back into the surface, and we can see we're now filtering precisely that zone that contains the feed rate. So our filtered data is looking at just those wavelengths surrounding the feed rate. So the wavelength content graph is an important tool for understanding perhaps the implications of your filter. Now we can always go deeper in profile analysis. In fact, that's why digital metrology provides OmniSurf, is for going into profile analysis. Fortunately for us, there is a toolbar button that will send this profile directly to the 2D OmniSurf software package. And here it is. We can do everything we want in terms of profile analysis in OmniSurf 2D with one click from OmniSurf 3D. So those tools are available as well. So let's get rid of some of these boxes now. We'll get rid of the wavelength content, get rid of the profile section, and look at a typical scenario in measurement. Typically, we'll look at lots of data, and we may need to summarize that somehow. So let's get set up for this particular data. I'm going to change my filtering because I know how to make this data look typical. That looks a little better for me. So now that I've got OmniSurf3D set up for these surfaces, I might want to process them all together and create a spreadsheet of results. OmniSurf3D gives us the ability to do that. We can export surface data sets and we can export parameters, but I want to generate a spreadsheet automatically using one of my favorite tools, batch processing. Batch processing will allow me to take all of the data from a given folder and put all of the results into a results file. So let's call it new results. And we're going to create a new results file with one click of the mouse. OmniSurf3D's batch processing is loading all of those files, and as it goes, it's creating a spreadsheet which we can automatically open here at the end with a click, and we see all of the results. Not only do we see the results, but we see all of the information behind them. We see the file that it came from, any pre-processing, geometry, any filtering, as well as any parameter settings that were used for that parameter calculation. With a spreadsheet generated, we can do things like create trend charts throughout our files. We can do SPC, we can do statistical processing of those results. So not only can we explore our data, we can summarize a ton of data. So there's a quick look. If you have 3D surface data, you need OmniSurf3D. For more information, check it out at digitalmetrology.com. If you have questions, send us an email. Thanks.